Hey, this is Professor Perez from Saddleback College again. We're going to continue our work with logarithms. Today we're going to work with a change of base rule. And so, most of the time, logarithms do require that you have a calculator to actually calculate them. So all you calculator kids out there, take out those calculators right now because you're going to actually use them. Okay, and of course we can't have a class without Charlie. He better be ready to go. Hey Charlie, you ready to go? Okay, here we go. Change of base formula. That's what we're going to do today. Now there's our first logarithm, log base 8 of 16. We did this logarithm in the previous video without a calculator. Do you remember what we got, Charlie?
No, 4.
Okay, let me remind you.
2?
It was 4/3 because 8 to the 4/3 was 16. Remember? 8 to the 4/3, the 3 in that exponent that was in the denominator, that fractional exponent, meant take the cube root of 8. And the cube root of 8 is 2, and 2 to the 4th is 16. That was from the last video. So anyway, here we go. Now we're actually going to do this with using the change of base rule, okay, without a calculator. Watch. Now, the change of base rule allows you to write a quotient of logarithms. But when you do this, each logarithm that you use, top and bottom, must be the same base. So let me explain this right here. Watch what happens. We have log base 8 of 16. And notice, on the top, I'm going to write log base 2 of 16. The reason I'm using a log base 2 is because we should be able to calculate log base 2 of 16. Charlie, what is log base 2 of 16? 4. It is 4 because 2 to the 4th is 16. Now notice in my denominator here, I'm going to write log base 2 of 8. Now, what is log base 2 of 8, Charlie? 3. It is 3 because 2 to the 3rd power is 8. Well, notice what we did here is we applied the change of base rule. So we took our original logarithm, which was a log base 8, and we rewrote it as a quotient of logs with base 2 logarithms, right? Because we can calculate log base 2 of 16 and log base 2 of 8 to get us this answer of 4/3, which we knew in the previous lecture that the answer was 4/3. That's because log base 2 of 16 is 4 and log base 2 of 8 is 3. Now if you take your calculator out and do 4 divided by 3, you should get 1.333. It goes on, right? And we'll leave our answer there, round it to the nearest hundredth. Now, if you're doing logarithms like in a chemistry class, you've got to pay attention to the significant figures. We're actually going to talk about that in our next lecture. Okay? But now, here we go. Same problem again. Log base 8 of 16. This time, we're going to use our calculator to do it. Now, keep in mind, your calculator only does log base 10, the common logarithm calculations, or it will do log base e, which we call the natural logarithm. You have those keys. They should be log and ln. Watch. Okay. This time, we're going to apply the change of base rule, and we're going to change it to a log base 10 so we can use our calculator, the common logs. Okay. Now notice here, we have log of 16, which denotes log base 10 of 16, and in our denominator, we have a log base 10 of 8, or log of 8. Remember, when you apply the change of base rule, your top logarithm and your bottom logarithm must be the same base. You can't put like a log base 10 on top and a log base 3 on the bottom. No, that's not what it says. You must have the same base in your logarithms. Now, why did we change it to base 10, Charlie? So you put in a calculator. We change it to base 10 so we can use our calculators. Now watch. Take your calculator out and calculate log of 16, and then you divide that by log of 8. Okay, go ahead, Charlie, and tell me what you get.
1.33. 3.
That's right, 1.33. Notice it's the same answer as the one we got before. Of course it is, the same logarithm. Okay, so let's do it again. But this time, we're going to use our base e's, or the natural logs. Now watch what happens here. Notice we have log base 8 of 16, and the change of base rule is going to allow us to write a quotient of logarithms, but this time we're going to use log base e's. Now watch. Log base e of 16, there we go, and log base e of 8. Notice the 16's on top and the 8's on the bottom, but we're using base e's. Now, instead of writing log base e the way it's written there, we kind of use a shorthand and write ln. Now, ln of 16 means the natural log of 16. And the natural log of 16 is actually log base e of 16. And you have a specific key on your calculator that says ln for calculating natural logs. And don't forget, on the top we have natural log of 16, and the bottom we have natural log of 8. And now you can take your calculator out and calculate natural log of 16 and divide it by natural log of 8. All right, Charlie, what do you get?
1.33.
That's right, it's the same thing, 1.33. So here we go. So on the top there, we did it without a calculator. The middle one, we applied the change of base rule and used log base 10s. And then the bottom one here, we use log base e's, which are the natural logs. And of course, we got the same answer, 1.33. Okay, now here we go, Charlie. Let's do another one. Log base 5 of 16. Now this does require that we use a calculator. So let's apply the change of base rule, and we'll go ahead and use the log base 10, Charlie. So what do we get?
Log of 16?
Right.
Divided by log of 5.
Over log of 5, that's right. Get your calculator out, all you calculator kids. Calculate log of 16 and divide by log of 5. And what do you get, Charlie?
1.727.
1.7227. Man, he's pretty fast. Now, here we're rounding to the nearest 10 thousandths. Now, if you're in a chemistry class, you got to be very careful with significant figures. We'll talk about significant figures when you do logarithmic calculations in our next video, okay? Now, here we go, Charlie. Log base 2 of 4. Do you actually need a calculator for this?
No.
Yeah, you do, if you don't understand what a logarithm is. But what's the answer going to be?
2.
2, of course, because 2 raised to the second power is 4. But let's go ahead and use our calculator. Okay, what do we get, Charlie? Let's use base 10 again. What do we have?
Log 4.
Log 4 divided by?
Log 2.
Log 2, that's right. Okay, Charlie, now take your calculator out. Log of 4 divided by log of 2. And what do you get, Charlie?
2.
2. That is just too good. Well, anyway, let's keep going here. Here we have a log base 8 of 0.25. Okay, so this one could actually be done without a calculator. So go ahead and try it. But let's use the calculator because we're too chicken to try it without a calculator. All right, Charlie. This time, let's apply the natural log. Let's use change of base with base e, natural log. Now watch. We have natural log of 0.25 divided by natural log of 8. Now take your ln key, got to get to it, ln of 0.25 divided by ln of 8. And what do you get, Charlie?
Negative 0.6667.
That's right, you get a negative 0.6667. It's a negative answer. Now, I want you to realize that this answer is actually negative 2/3. So, because 8 to the negative 2/3 is actually 0.25 or 1/4. So try that one on your own. Okay, let's do one more here. Negative log of 0.0025. Now, do we need to apply the change of base rule here, Charlie?
Yes. No?
No, why not?
So log base 10.
Because that is a log base 10. Your calculator does log base 10, so there's no need to apply the change of base rule. All you got to do is put in log of 0.0025. Remember, it's a negative answer. So, Charlie, take the log of 0.0025 and tell me what you get.
Negative 2.60?
Negative 2.60, that's right. Now don't forget, this is a negative log, so there's a negative outside. And remember, the negative of negative 2.60, or the opposite of negative 2.60 is what, Charlie?
2.60.
2.60, very nice. Okay, now we're going to do a couple word problems here. Okay, here is a earthquake.